Hey everyone, in today's video we're going to be looking at a collection of algebra problems to help prepare us for some of the stuff we're going to see in pre-calculus. Let's go ahead and get started. In number 1, the Pythagorean Theorem, a squared plus b squared equals c squared, where a and b are legs and c is the hypotenuse, can be used for any triangle to find the length of a missing side. Is this statement true or false? Well, if we look at the statement, it says any triangle. And we need to think back to the Pythagorean Theorem. Can we use the Pythagorean Theorem for any possible triangle? Well, the answer is no. Right triangles only. Right triangles only. All right, so this would be false. Taking a look at number 2, a flying squirrel's nest is 5 meters high in a tree. From its nest, the flying squirrel glides 8 meters to reach an acorn that is on the ground. Assuming the tree is perpendicular to the ground, how far is the acorn from the base of the tree? If necessary, round to the nearest tenth. Maybe draw a picture to help visualize the problem. So let's do that. Let's go ahead and draw a picture, because anytime we're dealing with a problem that can be visualized with the picture, probably a good idea. So we don't need to make it super complicated. We have our tree, and we have our acorn. So this little green dot here will be the acorn. And we have our squirrel up here at the top. And we know that the squirrel's nest is 5 meters high in a tree, so we know that this distance is 5 meters. And we know that from its nest, the flying squirrel glides 8 meters to reach the acorn. So from here to here, it's where the squirrel glides, we know that that's a distance of 8 meters. And we also know that the tree and the ground are going to form a 90-degree angle because the tree is perpendicular to the ground. So we can use Pythagorean's theorem, a squared plus b squared equals c squared. So what we are essentially looking for is the other leg, and I'm just going to call it x. So we know that the two legs, 5 and x, so 5 squared plus x squared, will equal the hypotenuse squared, which is 8 squared. So 25 plus x squared equals 64. Let's go ahead and subtract 25 from 64, and we're going to get 39. So x squared equals 39. Let's go ahead and take the square root of both sides. And using a calculator to make this approximation, the square root of 39 is approximately 6.2, and let's see, it says round to the nearest tenth, so about approximately 6.2 meters. Which would be B. Looking at question 3, consider triangle ABC and assume that it is a right triangle. If the length of side AB is 7 and the length of side BC is 13, calculate the length of side AC. So we are assuming that we have a right triangle here. So we're assuming the angle B is 90 degrees based off the picture. And we've already been told that the length of side AB is 7. And the length of side BC is 13. So we want to find the hypotenuse. And how do I know that AC, or what I'm calling x, is the hypotenuse? Well, recall that the hypotenuse is the side that's directly across or directly opposite of the 90-degree angle. So once again, because we have a right triangle, we can use Pythagorean's theorem. We can say a squared plus b squared equals c squared. We know a and b, the legs, are 7 and 13, so 7 squared plus 13 squared equals x squared. Well, 7 squared is 49, 13 squared is 169. Let's add those together. That'll give us 218. So x squared is equal to 218. 218. And then now let's go ahead and take the square root of both sides so that we can isolate for x. And this will tell us that x is approximately equal, because we are rounding to the nearest tenth, so the square root of 218 is approximately 14.8. So x is about 14.8. Looking at number 4, solve the following equation for w. So this is going back to Algebra 1, just solving equations with variables. So let's go ahead and distribute the 5 And we would get 5 times negative w is negative 5w, 5 times 6 is 30, plus 7w equals negative w minus 6. Combining like terms on each side, so negative 5w and 7w would combine to make 2w plus 30 equals negative w minus 6. And now we want to go ahead and get variables on the same side. So I'm going to take the negative w and I'm going to add it to both sides. This will give me 3w plus 30 equals negative 6. Now we need to work on isolating the variable, so we'll subtract 30 from both sides. We get 3w equals negative 36. And then lastly, we need to divide the coefficient 3. And this will tell us that w equals negative 12. Which is D. Looking at number 5, solve the following equation for x. Type your answer as a number only. Do not include the x equals. So for a problem like this, a lot of students might get a little apprehensive at first because of the fractions. Well, we actually have a neat way to eliminate all fractions in a problem. If we look at the denominators 3 and 5, well, let's think of the LCM, the least common multiple of 3 and 5. Well, the LCM of 3 and 5 would actually be 15. So one thing that we can do is once we have found that the LCM of 3 and 5 is 15, we can multiply all terms of the equation by 15. So let's see what happens. 15 times x over 3 plus 15 times x minus 2 over 5 equals 15 times 6. Well, 15 times x over 3, well, 15 times x is 15x, and 15x divided by 3, this would turn into 5x. If we look at the next one, well, the 15 and the 5, they can reduce with each other, and that would just make a 3, so we would have 3 times x minus 2. And the 15 times 6 would be 90. So continuing to simplify this problem, if I distribute the 3, I would have 5x plus 3x minus 6 equals 90. 5x and 3x makes 8x minus 6 equals 90. Adding the 6 to both sides would give us 8x equals 96. And then dividing 96 by 8, we would get that x equals 12. And this would be our answer. Number 6, solve the following equation for v. So we have another problem where we're solving an equation for a variable. In this case, we have 1/2 times 5v minus 2 equals 2v plus 4. Well, again, a lot of students might get a little apprehensive about a problem like this because of the presence of the fraction 1/2. Well, we have a way to handle that 1/2. One thing we can do is we can look at the reciprocal of 1/2, which is 2, because 1 over 1/2, flip the numerator and denominator, flip the fraction upside down, you'd get 2 over 1. So let's multiply both sides of this equation by 2. So 2, let's get the auto shape off, 2 times 1/2 times 5v minus 2, so I'm multiplying the left side by 2, and then I also need to multiply the right side by 2. 2 times 2v plus 4. Well, the nice thing here is that the 2 and the 1/2 are multiplicative inverses of each other. We'll just get a 1. So on the left side, we're left with 5v minus 2. On the right side, distributing the 2, we would get 4v plus 8. And now we go about our equation solving process. Let's go ahead and subtract 4v from both sides. That would give us 1v on the left. If we added 2 to the right side, or added 2 to both sides, we would get 10. And we now have that v equals 10, which means our answer is A. Number 7, solve the following equation for C. Make sure that your answer is fully simplified. So let's go ahead and work on getting all of the variables to the same side. So negative 75c squared plus 99 equals negative 74c squared. I'm going to go ahead and add 75c squared to both sides. And this is going to leave me with 99 equals c squared. So let's go ahead and take the square root of both sides. And what's going to end up happening here is when we take the square root of 99, we need to make sure that we include both the plus and minus, because we're going to get two different solutions here. So, and let's also think about what the square root of 99 might be. Let's do a little bit of side work here. So square root of 99, well, 99 is simply 9 times 11. And we know that the square root of 9 is 3, so this would be 3 square root of 11. So we know that we can simplify square root of 99 to plus or minus 3 square root of 11. And the square root of c squared, well, the square root and the power of 2, they eliminate each other, and we're just left with c. So c is plus or minus 3 square root of 11, which would be c. Looking at number 8, solve the following equation for x. So now we see an equation that involves a square root. So when we have an equation that involves a square root, we were trying to isolate the square root. So let's go ahead and begin by adding 7 to both sides, which would result in square root of 5x equals 20. Now we must ask ourselves, well, what's going to get rid of a square root? Well, just like in the previous problem, we took a square root to get rid of a power of 2. So to get rid of a square root, we can use a power of 2. So let's raise both sides of the equation to the power of 2. On the left side, the square root and the power of 2 will cancel. We'll have 5x. Let me make this green to be consistent. So we'll have 5x. And on the right side, 20 squared would give us 400. Dividing both sides by 5, that leaves us with x equals 80. So the correct answer is D. Problem 9. Write g of x as the inverse function of f of x equals x minus 4 to the third power, or x minus 4 cubed. So recall that when we were trying to find an inverse function, so here's our function f of x equals x minus 4 to the third power. Recall that if I want to find the inverse function, well, let's replace f of x with y. And now let's switch the variables x and y together. So instead of y, we'll have x. Instead of x, we'll have y. And what we want to try to do now is solve for y. We want to try to isolate y. Well, to get rid of, or to remove the power of 3, let's go ahead and take the cubed root of both sides. So on the left side, we'll have the cubed root of x. On the right side, we'll simply have y minus 4. And then to isolate for y, we'll just add 4 to both sides. So now we will have cubed root of x plus 4 equals y. And this is now our inverse function, once we rewrite that in function notation. And that is answer choice B. All right, question 10. True or false, g of x is the inverse of f of x? Well, let's look at f of x. We can see that f of x is negative 5x minus 4. Again, let's replace f of x with y. And let's go ahead and switch x and y together. And we want to try to solve for x, or we're going to try to solve for y now. So let's add 4 to both sides. So we now have x plus 4 equals negative 5y. And then you're going to notice when trying to solve for y, when trying to isolate y, we have to divide negative 5 on both sides of the equation. So we would end up getting that x plus 4 divided by negative 5 equals y. But that isn't what we're getting here. They're not equal to each other. So this would be false. G of x is not the inverse of f of x. Looking at problem 11, consider the graph of the quadratic equation y equals x squared plus 3x plus 2. Select all the following statements that are true. So A says the domain of the function is all real numbers or negative infinity to positive infinity. And this would be true for every single quadratic function The domain of the function is going to be all real numbers unless you are given some parameters to limit the domain. Since we are not given any parameters, this would be true. Now let's look at statement B. The range of the function is all real numbers greater than or equal to 2, or y is greater than or equal to 2. Well, if we look at 2 on the y-axis, which would be this point right here that I'm highlighting in blue, you can still see that all of this that I'm kind of highlighting here in blue is below that point. And remember that the range is the collection of y values, or the collection of outputs. And we have several outputs that are below 2. So this would be wrong. This would be incorrect. So I'm going to put an X there. Statement 3, the quadratic equation has 2 real roots. Well, let's look at our roots. Remember that a root is an x-intercept. So we have 2 x-intercepts, one at -2, 0, and one at -1.5, or sorry, -1, 0. So yes, we have 2 real number roots. So this is correct. Statement D, the vertex of the quadratic is located at -1.5, -0.25. So recall that the vertex is either the lowest, the minimum, or maximum point of a quadratic. And indeed, the minimum point here is -1.5, -0.25, so that is correct. And then statement E, the quadratic is increasing on the interval -infinity to -1.5. Well, remember that increasing means that on that interval, from left to right, the y values are getting larger. Well, if we look from -infinity to -1.5, and we're talking about the x values, by the way. When we talk about intervals, we talk about x values. So if I look from -infinity all the way to -1.5, so -1.5 stops right there. You can see the x value at -1.5. We can actually see that these y values were decreasing. So that is not true. Problem 12, consider the graph of the polynomial equation y equals -x cubed plus 3x squared minus 2 given to the right. Which of the following represents the correct interval or intervals of decrease? So again, an interval of decrease is an interval or a range of x values for which the y values are getting smaller between those x values. So if I start to trace the graph, this is how I look at intervals. Well, from left to right, notice the little arrows that I'm putting on the graph here. These show kind of the direction the graph is taking. So I'm going to highlight in yellow where the graph is decreasing, where essentially we have down arrows. And we want to find the x values that happened for. So basically, all the way from the left until we got to the x value of 0, the graph was decreasing. So that interval would be represented as -infinity to 0. But also notice from the x value of 2 and onwards to the right, we're also decreasing. So from 2 to infinity is another interval of decrease. So we would bring these two intervals together with a union sign. So it turns out the correct answer is -infinity to 0, union 2 to infinity. Problem 13. Basically, consider the same polynomial from problem 12. Which of the following represents the in behavior? So in behavior really works as directions. We want to know what's happening on the left and right end of the graph. Well, if I look at the right end of the graph, which is right over here, what do the y values appear to be doing? Well, it appears on the right side of the graph, the y values, or the function values, are decreasing without bound. So how do we represent that with notation, proper notation? Well, as x approaches infinity, think about x. X is the horizontal axis. If x goes to infinity, that means x is going to the right. So as x goes to the right side, we already determined that the y values are going down or decreasing. So as x goes to infinity, y is going to -infinity, because for the y-axis, down would be approaching -infinity. Now let's talk about the left side. So I'll highlight the left in blue. Well, now we're approaching the left side of the graph. We're going to the left. So if x is going to the left, then x would be going to negative infinity. So as x goes to negative infinity, that means x is going to the left. Well, what's happening on the left side of the graph? We can see that on the left side of the graph, the y values are increasing without bound. So y values increasing means that y is approaching positive infinity. So that would be answer choice B. Number 14, simplify this expression. Write your answer in the form a plus bi. So notice that we're working with complex numbers now. Complex numbers have a real part and they have an imaginary part. So when adding or subtracting complex numbers, we would add or subtract the real part, add or subtract the complex part, and make sure we write in the correct form. So let's go ahead and make sure we're careful with how we're going to distribute. So we need to distribute the negative signs here. So we would get negative 16i minus 17 minus 16 plus 2i plus 20. So now let's go ahead and add the real parts, which I'll highlight in green. So negative 17 minus 16 plus 20, if we added those all together, we should get negative 13. And then let's go ahead and add the imaginary parts together, 2i and negative 16i, and that would give us negative 14i. Now we are in the correct form, a plus bi, where the real part is first, the imaginary part is second, and that would be answer choice B. Number 15, simplify. So now we're multiplying complex numbers. Let's go ahead and we would distribute the negative 5i. So negative 5i times negative 5 would be 25i. Negative 5i times positive 2i would be negative 10i squared. Now recall from Algebra 2 that I is the square root of negative 1, which means that I squared would be negative 1. So we can say that negative 10i squared is negative 10 times negative 1, and this would give us, well, negative 10 times negative 1, that's positive 10, and then plus 25i, because 25i has no like terms, and that would be our answer right here. Okay, 10 plus 25i. Notice again that I'm putting the real part, which is 10, before the imaginary part, which is 25i. All right, problem 16. We have complex number multiplication. I am a big fan of using the area method, or an area model, or also known as the box method, to represent multiplication, because I think it presents it in a very visual way. So I'm going to go ahead and set up a box. And the dimensions of the box come from how many terms we're multiplying by. So notice that this is a binomial, or two terms here, so I have a 2 by 2 box. So we have negative 2 minus 5i root 7, and then we have negative 1 minus 4i root 7. Well, let's go ahead and multiply. Well, negative 1 times negative 2 is positive 2. Negative 2 times negative 4i root 7 is going to be positive 8i root 7. Negative 1 times negative 5i root 7 is 5i root 7. And then negative 5i root 7 times negative 4i root 7, that's going to give us positive 20i squared. And square root of 7 times square root of 7 is just 7. So now let's do some simplifying here. Well, 2, then we have an 8i root 7 and a 5i root 7, which would give us 13i root 7, because we're adding the coefficients but keeping the square root the same. And then we need to look hard at this piece right here. 20i squared times 7. Well, we know 20 times 7 is 140, and then I squared is negative 1, so that would be minus 140. Combining like terms, 2 plus negative 140, or 2 minus 140, would give us negative 138 plus 13I root 7. And that would be answer choice A. Problem 17, write the complex conjugate of 5 minus 3a, write the answer in the form a plus bi. Well, recall that the complex conjugate of a complex number, well, if we have a complex number a plus bi, then the complex conjugate would simply be a minus bi. Complex conjugate. So with that in mind, the complex conjugate of a plus bi, or sorry, 5 minus 3i, would simply be 5 plus 3i. Problem 18, simplify negative 1 plus I divided by negative 4i, write your answer in the form a plus bi. Well, in a problem like this, what we want to do is go ahead and separate the fraction into different pieces. So negative 1 plus I over negative 4i, I'm going to separate into negative 1 over negative 4i plus I over negative 4i. So I'm taking the denominator and I'm splitting it into two separate fractions. The reason that this is helpful for us is because we can now see, you know, the negative 1 over 4i, that's going to become positive 1 over 4i. And the I over negative 4i, well, we can see that the i's are going to cancel each other and we get minus 1/4. Now, one of the problems, though, that we're going to run into is that we don't want I to be in the denominator. So we need to think to ourselves, what can we do to remove I? And I'm talking about right here. What can I do to get rid of that I in the denominator? Well, I can multiply both the numerator and the denominator by I. By multiplying by I over I, I'm not changing the expression because I'm only multiplying by 1. I'm just multiplying by 1 in a clever way. So let's see what happens when I do that. Well, in the numerator, 1 times I is I, but in the denominator, 4i times I is 4i squared. And we know that I squared is negative 1. So negative 1 times 4 would give us negative 4. So now we have removed the I from the denominator, but we still need to write this in the correct form a plus bi. So the negative 1/4, the real portion, would go first, and the negative 1/4 I would go second, and that would be answer choice C. All right, problem 19. Simplify 7 plus 7i divided by 1 plus I. So there are a couple ways to handle this problem. We could try to multiply the numerator and denominator by the complex conjugate, which would be 1 minus I, because the complex conjugate of 1 plus I is 1 minus I. But I see a more efficient way to handle this problem. If we look at 7 plus 7i and 1 plus 1i, well, in the numerator, we could factor a 7. If I factor a 7 out of the numerator, I'll be left with 1 plus I. And notice we have a 1 plus I, a factor of 1 plus I in both the numerator and the denominator, which would cancel with each other. And all we would have remaining is 7. All right, and then lastly, last problem here in our review is to simplify negative 5 plus 3i divided by negative 5 minus 3i. So another dividing complex numbers problem. And this time we're not going to be so lucky with the method that we saw in number 19. We're not going to be so lucky with the problem. So what we need to do is we need to take our problem, so negative 5 plus 3i, divided by negative 5 minus 3i, and we need to multiply by the complex conjugate of the denominator. So the conjugate of negative 5 minus 3i is going to be negative 5 plus 3i. Let's multiply that to both the numerator and the denominator. And let's see what ends up happening here. Well, in the numerator, negative 5 plus 3i times negative 5 plus 3i, well, that's a box method problem, so let's go ahead and multiply it out. So we're doing some side math here. So that's going to give us 25, negative 15i, negative 15i, and 9i squared. Well, simplifying that, we're going to get 25 minus 30i minus 9. Because again, remember the I squared is negative 1. Negative 1 times 9 give us negative 9. Now, go ahead and simplify. Well, 25 minus 9, that's going to give us 16. So we have 16 minus 30i. So that's our numerator. Now let's try to simplify the denominator. So we're going to again do a little bit of side math here. We're going to set up another box, because we're doing more box method multiplying. But now we're multiplying negative 5 minus 3i times negative 5 plus 3i. So let's see, negative 5 times negative 5, that's going to give us positive 25. 3i times negative 5 is negative 15i. Negative 3i times negative 5 is positive 15i. And then negative 3i times 3i is going to be negative 9i squared. So when we try to simplify this now, well, we're still going to get 25. But this time, notice that the negative 15i and the 15i cancel each other. And the negative 9i squared, well, again, I squared is negative 1. Negative 9 times negative 1 is going to be positive 9. And then 25 plus 9, that's simply 34. All right? So the denominator turns into 34. Now we want to go ahead and separate the fractions so we can write our answer in the form a plus bi. So we have 16 over 34 minus 30 over 34i. Well, 16 over 34, those can both be divided by, those two numbers are both divisible by 2, so this would be 8 over 17 when we reduce that fraction. And 30 over 34, also both divisible by 2, that would be 15 over 17. So we have 8 17ths minus 15 17ths I, and that would be answer choice